Assalamualaikum and hi everyone. So in this slide, I will explain about one of the principle in physics, which is known as Bernoulli principle. So for information, Bernoulli principle is the principle that related to the pressure. So without wasting our time, let's know more about Bernoulli principle. So here's some of the video for your brainstorming. Have you ever wondered how does the takeoff of plane happen and what happen when you blow a piece of paper? So this situation have the relationship with the Bernoulli principle. So what is actually Bernoulli and who found out this principle? So let's know more about Bernoulli. So the name of Bernoulli itself is come from Daniel Bernoulli, which is the physician, the person who found out about the Bernoulli principle. So Daniel Bernoulli stated that when the velocity of the fluid increase, the pressure in the fluid will decrease and vice versa. So in this context, we need to understand that the fluid mentioned by Daniel Bernoulli is different with liquid. Fluid are the substance that are in a physical state of being solid, liquid or gases. So fluid does not only refer to the liquid, but it also can be gas. Alright, so please take a note on that. So now we'll discuss back about the situation when we blow a piece of paper. So as we blow the top of the paper, the air will move faster on the top section compared to the bottom section. So the Bernoulli state that when the velocity of the fluid increase, the pressure will decrease. So the high pressure on the lower part of the paper will push the paper upwards. So that's basically what happens when you blow a piece of the paper. Alright, next, let's see the other situation, which is Venturi tube. So for the Venturi tube, we connect the water tap on the tube. So the water will flow from water tap to the sink. So the water that flow from the water tap, it comes with the high pressure of water. So when there is a high pressure, the velocity of the water will become low. So it causes the height of the water column at A region is higher compared to B and C because the pressure in the X region is higher compared to Y and Z. Meanwhile, uh, at Y region, the water will move with high velocity because of the size of the tube is smaller compared to X and Z. So when the water moves with high velocity, it will create a low pressure of water. So the height of the water column at B, as we can see in this picture, is lowest compared to A and C. So basically, the velocity of the water on the Venturi tube situation is depends on the cross sectional area of the tube. Alright. So next, when we talk about Bernoulli principle, there is a concept that we call a lift force. Actually, lift force produced when the pressure in lower part of the object is greater compared to the upper part. So when there is a difference in pressure, it will produce a lift force that acts upwards towards the object. Alright. So here's the video about the overview of the lift force. Alright, so as you can see in the previous video, there is a sample of aerofoil kit which the factor that cause the lift force. So actually, the aerofoil shape is the curved shape which been installed at most of the aircraft wings. So when we talk about aerofoil shape, when the airplane is moving, it will create two different region, which is uh, top region and bottom region. So the top section of the aerofoil will create a low pressure because the air move faster on the top section. Meanwhile, at the bottom section, the air will move slower compared to the top section. So it will create the high pressure on the bottom section. So when there's a difference between pressure between upper parts and lower parts, it will create the lift force that acting upwards because the pressure in the lower part is greater compared to the upper part. So the object or the airplane will lift up. Alright, now let's see the other situation of lift force is a ping pong ball. So when we put a ping pong ball on the filter funnel and we blow the air through the funnel, the ball will not falling down. This situation occur because the air flowing with the high velocity above the ping pong ball. So there is they will create a high pressure on the upper parts on the lower parts of the ping pong ball. Meanwhile, on the lower part of the ping pong ball, it will create the high pressure of the air. So the high pressure on the bottom part of the ping pong ball will push the ping pong ball towards the wall of the filter funnel. So it will keep the ball stay at the wall of funnel. Right. So Bernoulli principle is widely used in our daily life without our consent. So let's check it out. What's the application? Okay, first is the situation when we are using a Bunsen burner in a lab or somewhere else. So when we open the gas supply, the gas will flow out with high velocity in the Bunsen burner. So it will create low pressure in the Bunsen burner. So at the body of the Bunsen burner, there is a air hole. The function of the air hole is to allow the external atmospheric pressure to enter to the Bunsen burner. So when the high atmospheric pressure flow into the Bunsen burner, it will mix with the gas in the Bunsen burner to allow more complete combustion to occur. So if we want to know there is a complete combustion, you can see the blue color of flame is occur. So lastly, the application is the production of downward force on the racing car. So as you can see, the spoiler and the splitter of the racing car is made with the inverted aerofoil shape. So the bottom section of the aerofoil will allow the high velocity of air flows. So it will create the low pressure on the bottom section. Meanwhile, on the top section, it will create the high pressure because the air flow with a low velocity on the top section. So the difference in pressure will create the downward force. So the function of the downward force is to make the F1 car is more stable and doesn't fly off easily. So as the conclusion, Bernoulli principle gave a lot of benefits in our daily life. So basically, there is have a lot of Bernoulli application in our daily life without our consent. Here I put the link for your reference on the last slide. I think that's all from me. I hope you can learn something from my video. Thanks for watching.